Okay, we're looking at the 5C practice test for AP Stats. First question, multiple choice section says, a nutritionist wants to study the effect of storage time, 6, 12, and 18 months on the amount of vitamin C present in freeze-dried fruit when stored for these lengths of time. Vitamin C is measured in milligrams per 100 milligrams of fruit. 6 fruit packs were randomly assigned to each of the 3 storage times. The treatment, experimental unit, and response are respectively. So the first thing, the treatment is how long you store it. So you can immediately rule out B and C. The experimental units are the things involved that you're studying. And it said that we are looking at 6 fruit packs were assigned to each of 3 storage times. So the fruit packs are the units. So we can rule out E, and we can rule out A, which means it has to be C. And finally, so then the response is the amount of vitamin C that you can find in the fruit packs. Question 2 says, we wish to investigate if a new medicine is effective in reducing the length and severity of the flu. We take the next 20 patients who come to the walk-in clinic complaining of flu, and after a medical exam to verify that the patients do have the flu, give them the new medicine and tell them about the new drug we are giving them. 1 week later, the patients are contacted, and 15 patients state that the new remedy was helpful in reducing the severity and length of the illness. Which of the following is not correct? So I went through all these and looked at them, and the one that's not correct is it says this is a poor experiment because we didn't give the remedy to people without the flu to assess its effect in a control group. So this is a poor experiment because we didn't give the remedy to people without the flu to assess its effect in a control group. That is not true, so it's not correct. Okay, question 3. An experiment to measure the effect of giving growth hormones to girls affected by Turner syndrome was carried out recently in Vancouver. All 34 girls in the study were given the growth hormone, and their heights were measured at the time the hormone was given and again 1 year later. No measurements were made on their final adult heights. Which of the following is not a problem with this experiment? So when they ask not a problem, that means 4 of these things are an issue with the experiment. There was no blinding. That could be a problem with the experiment. There's no control group here. That's another problem. They didn't think about the placebo effect at all. Maybe some people were growing because they thought they were given a real treatment, and they weren't given a treatment. They also didn't measure their final adult heights, so how do you know if the hormone treatment actually helped them grow in the long term, or just helped them grow, gave them a little growth spurt initially, and then they didn't actually grow enough by the time they reached adulthood? So that's a problem also. So the only one that's not a problem here is C, non-response bias. Non-response bias is basically when you contact people hoping to get replies and you don't get replies from some of them, which is not even part of the situation in this problem. Okay, next question. Question 4 said, a survey is to be administered to recent nursing graduates in order to compare the starting salaries of women and men. For each graduate, 3 variables are to be recorded: sex, starting salary, and area of specialization. So we're looking at explanatory response variables here. And since we want to compare the starting salaries of women and men, the explanatory response variable would be the gender, the sex of the person, and the response variable would be their starting salary. So sex and starting salary are explanatory. Starting salary is not explanatory, it's not A. Sex is explanatory, starting salary and area of specialization are response variables. The area of specialization is some outside variable that might help you see what their starting salary is. Because a nursing graduate who specializes in maybe neurosurgery, which is, surgery on the brain, versus someone who's just like a general nurse, like maybe a pediatric nurse, like a child's nurse, the person who has a specialization is probably going to make more money because they have more technical knowledge. And so that's not a response variable. If you look at C, the area of specialization, that makes sense as a confounding variable. So we're going to go with C on number 4. For question 5, it says a researcher wishes to compare the effects of 2 fertilizers on the yield of a soybean crop. She has 20 plots of land available and she decides to use a paired experiment using 10 pairs of plots. Thus, so what she wants to do here, if she's going to use 10 pairs of plots, is to split them into pairs. And then, so you want to make the plots as similar as possible. That's what a paired experiment is a way of blocking. And then within each of those pairs, they need a 50-50 chance of being either given, one treatment or the other treatment. So one way you can do a 50-50 chance is by flipping a coin. You flip a coin, say the first one, if it comes up heads, the first plot in that pair is one treatment. The other plot in that pair is automatically the other treatment. So question 5 is B. Question 6 said a study of cell phones and the risk of brain cancer looked at a group of 469 people who have brain cancer. The investigators matched each cancer patient with a person of the same sex, age, and race who did not have brain cancer, and then asked about the use of cell phones. This is an observational study because they're not doing any treatment. They're just looking at a person who has cancer against a person who doesn't have cancer and asking them about how they use their cell phone. They're not doing anything to these people. Question 7 says a class in marketing designs 2 videos advertising an expensive Mercedes sports car. They test the videos by asking fellow students to view both in random order and say which makes them more likely to buy the car. Mercedes should be reluctant to agree that the video favored in this study will sell more cars because E, the results from students who are in college, or this could be even high school students, may not necessarily generalize to the older and richer customers who might buy a Mercedes. So just because an ad is targeted to appeal to a certain age group doesn't mean it's going to appeal to every age group. I would argue for Mercedes that their target customer is an old rich person, because there's not very many kids who are going to be like, ooh, a Mercedes is the ultimate car for me to get. So just because they like that commercial as a young kid doesn't necessarily mean the target audience, which would be older and richer people, would also like the advertisement. Question 8. Consider an experiment to investigate the effectiveness of different insecticides in controlling pests and their effects on subsequent yield. What is the best reason for randomly assigning treatment levels, spraying or not spraying, to the experimental units, which are the farms? So the best reason to randomly assign stuff is that randomization tends to average out the other uncontrolled factors, which means the other confounding variables. In this situation, they could be the soil fertility, so that they're not confounded with the treatment effects. Basically, that's the whole point of randomization, is that you average out the effects of confounding variables. Okay, free response questions. Number 9. In a 1995 Corporation for Public Broadcasting poll of TV viewership, one question was, a recent study by a psychology professor at a leading university concluded that the amount of violence children see on television has an effect on their likelihood of being aggressive and committing crimes. From what you have seen or heard about this subject, do you agree strongly with that conclusion, agree somewhat, or disagree strongly? Is that question appropriate, or is it flawed in some way? Comment briefly. So pretty much what they want you to see here is they're leading you into feeling that violence as a kid that you see on TV affects how aggressive and violent you're going to be later on in life. What that means is that the wording of the question predisposes the respondent, the person who's responding to the question, to assuming that TV violence causes aggression and crime, which is thus introducing bias into the situation. Question 10. You have been asked to select 20 participants for a drug trial that compares two different treatments for migraine headaches. The researchers have requested a block design, male and female, so we're blocking by gender, with control groups for each block. You have been given a list of people willing to participate in the trial numbered from 01 to 87. The first 42 people are female, the rest are male. So right off the bat, I know if there's 01 to 87, there's 87 people, 42 are female, that means 45 of them are male. So part A says we need to sketch a diagram for the design of this experiment. They wanted a block design, so the first thing we're going to do is we're going to block the people off by their gender. So the first group, so like we're splitting people up by gender. So it's like there's a possible one block is all the 42 females. The second block is the 45 males. And within each group, so because we want 20 participants, we're going to pull 10 people in each of our groups. And in the first group, the 10 people that are female, we're selecting 10 out of the 42 females. And in group 2, the males, we're selecting 10 people out of the 45 males. So within each group, it says that we need to have a control group with each block. So we're going to have a treatment 1, treatment 2. One of these will be giving them the headache medicine, and one of them will be the control group. So within each of those, we need half and half of 10, which is 5 people for each. We're going to measure the results. We're going to do the same thing down here for the males, split into 2 treatments. One of them is the medicine, one of them is the control. Each has 5, measure the results, and then finally we compare the results. So that's your sketch for what the diagram of the design of the experiment. Part B, in paragraph form, clearly explain how you will select the subjects for each group. So within a female block, I know that there's 42 potential subjects. There's 42 females. So what I'm going to do is I'm going to take the 42 people and put them in alphabetical order and assign them numbers 00 through 41. Then I'm going to go from the random digit table. The first 5 numbers that I see without repeats will be placed in treatment 1, and the remaining 5 subjects will go in treatment 2. I'm going to ignore 42 through 99, and I'm going to count every 2 digits. So like when I'm looking at the lines down here, like I would go 58, that's a number, 58, that's a number, 08, that's a number, etc. And then I also included in part B that I'm going to do the same process for men, except because there's 45 males, I'm labeling the males 00 through 44. I'm ignoring 45 through 99 in repeats, and I'm going to start from some different place on the random digit table. Otherwise, if I started from the exact same place that I started for the girls, I would get the same numbered subjects for each block. Part C says, beginning at line 123, find the 10 women. So I just started at 123. I blocked every 2 numbers, circled the 10 people I found, and labeled them here. Then I started at line 125 for the men, found 10 people, and labeled them here. Okay, question 11. The Student Council has been asked to determine the attitude of the students at your school toward a new dress code policy. Joe, a member of the council who's taking AP Stats, decides to send a questionnaire to an SRS of 100 students. 87 students return the completed questionnaire. Joe decides to randomly select 13 additional students to serve as replacement subjects to complete the sample of 100. Is Joe's sampling method appropriate? Briefly comment on the merits of this method or its pitfalls. So basically here what I said is that 13 additional students essentially had 2 chances of being selected for the study because they could have been picked out of the first SRS of 100, and then they also could have been picked again. So they had twice as much chance of being picked, which means the method is not fair and it's biased. Last question. Here's a quick and easy way to randomize. You have 100 subjects, 50 women and 50 men. Toss a coin. If it's heads, assign the men to the treatment and the women to the control. If the coin comes up tails, put the women in treatment and the men in control. This gives every individual subject a 50-50 chance of being assigned to treatment or control. Why isn't this a good way to randomly assign subjects to treatment groups? The reason this isn't is because there could be other confounding variables related to gender. Maybe the men and women respond differently to different treatments. And if they do, then there's bias in the problem. So basically, you shouldn't have like a homogeneous group. It shouldn't be like all the women do this, all the men do that, because that's not fair. You should have some of each within each group. Okay, that's the whole practice 5C test.